would like to invite Mark Ryland, Director, Office of the CISO at Amazon Web Services, to share with us his experience and story and case studies, and to get to this story with your experience. So please, Mark, welcome you.
So good afternoon, everyone. Thanks for including us here. Again, my name is Mark Ryland. I work for our Chief Information Security Officer, Steve Schmidt, and I have a global remit working with customers around the globe to both engage with them around their needs, explain our capabilities, and then work with our service teams as well to make sure that we're meeting those customer needs. So I'm going to talk briefly today, and I'll leave some time for questions around our approach to security. But before I do that, I have to tell you a little bit more about cloud security. It's not always fully understood just how far we've come and how many customers we have running very sensitive workloads. Securities are, we call it priority zero, meaning long before we even get to priority 1, 2, and 3. Security is really the most important attribute of a multi-tenanted large-scale cloud system. Now we understand that term broadly, as we should, to include not only confidentiality, but also integrity and availability. And so we design for that from the start, and we prioritize that. We make it a super high priority. We use a lot of automation. We'll talk more about that in a moment. But also, the key thing that we do to make this system effective for our customers is we provide them with lots of capabilities. So when you talk about cloud security, people are naturally curious in understanding how we secure our portion of the cloud. And that's a very reasonable question, and we'll talk more about that in a moment. But I think the perhaps even more important takeaway is how our customers use the cloud to provide even better security in their cloud-based environments than they can achieve on premises. It sounds strange if you're not deep into cloud technology, but this is a fairly routine conclusion of our customers. I can produce many quotes from very significant institutions and governmental bodies, banks and so forth, where they simply state we're more confident in the security of our cloud-based workloads than we are in our on-premises workloads. Now, why would they say that? I'll give you a very brief summary of that, and then we'll talk more about how we secure our side of this shared responsibility between customer and cloud provider. Here's some quick thoughts on that. So, number one, visibility. So you can't secure something unless you know whether you have it or not. So if you look at the SANS Institute top 20 control list, the first 3 of those, so a substantial portion, 15%, are about inventory. It sounds very boring, but very fundamental, that if you don't know whether you have something, you can't do anything to secure that. And I was in Berlin a couple of weeks ago speaking at our summit. I had dinner with a customer who told me about a bad day that they had a very large German organization where a couple years before, where they were meeting with their audit team, and the audit team said, we found 1,100 servers in the DMZ that we don't know what they do. So it sounds crazy, but it's not unheard of, right? It's very, very difficult to maintain an accurate configuration management database in a physical environment, because it requires that some human always follow exactly the right process when they jack in a network cord, or they bring in a rack of servers, or they do any type of modification. They really need to go type something into a console and update the database. And that, as you know, frequently doesn't happen. And the power of software-defined infrastructure, whether you build something for yourself on premises that's a software-defined infrastructure, or whether you use a cloud platform, is when you define things with software, when everything to define the infrastructure is an API call, then really what you're doing is you're updating a database. That's the first thing you're doing when you make an API call. Now, there's a workflow from that database. The workflow will go and actually change the physical reality such that your virtual servers are created, or your virtual networks are created, or your route tables, or what have you, subnets. All that stuff will get created as a result of that API call. But if you think about it, it's that first step in that process is to record a change in a database. And now you have an extremely accurate record of everything in the environment, which we, of course, bill you for as well. So we have a strong incentive for that to be accurate. But the key thing is there that the discoverability is really important. And then in addition to that, we have services, in our case, we call this AWS Config, which actually maintains a change history of those databases as well. So you can actually go back in time and say 3 weeks ago. So for example, you get a report from an external party that says, hey, there's an IP address from Amazon EC2 that belongs to you. We get an abuse report. We contact you and say this IP address is doing port scanning. So you may say, well, gee, you go and look in your environment, it's gone. That IP address doesn't exist anymore. Well, fortunately, with this other service, you can say, well, 3 weeks ago it did exist, and 4 weeks ago it was attached to a server by this such user. So you have this complete change record of all these properties of your system, and of course this is extremely valuable from a security perspective. So visibility is a really key property of these modern software-defined infrastructure systems. Obviously, automation goes hand in hand with that. If everything's an API call, you write code to make changes, and you've all heard these things about secure DevOps, software as code. We'll talk more about that in terms of how we operate, because that's a big part of our model. And then finally, scale alone actually is a huge benefit in many, many ways. I can mention just a few, but one, for example, is you have access to incredible resources to meet your needs, but also to react to situations that you may encounter. We have scale benefits, obviously, in terms of we can hire some of the world's best cybersecurity engineers, give them lots of interesting work to do, but if you look at the engineer to server under management ratio, it's extremely efficient. We have a vast number of systems, highly automated systems, and relatively speaking, a small number of humans involved in managing and configuring and keeping those systems secure. So anyway, that's kind of my the introductory material about cloud computing in general. And again, the reason it's of course a shared responsibility. Customers have to do the right things. We have lots of aids to help you do that. We build a lot of tools to make sure that you configure and manage and use your services in the right way. But the key thing is we've reduced the surface area dramatically of the things that you need to worry about. So now, just to use control language like a compliance person would use, let's say there's 200 controls that you have to be familiar with, taking care of, managing, and updating. In a cloud platform, roughly about 50% of those controls will essentially be handled for you by the cloud. The rest of them are still your responsibility, but the cloud will make it easier through automation, and you can concentrate your resources on a much smaller set of problems. So again, it sounds like a sales pitch. I suppose it is a sales pitch. But realistically, talk to customers that have gone deep in cloud, and I think you'll find that, again, maybe somewhat to your surprise if you're not deeply into this technology, that they're in general very, very happy with the security capabilities they're getting from the platform. So let's talk about the platform itself. So even though, again, one more example of the split between sort of customer issues and the platform issues. I come from the United States, you can probably tell by my accent. And I worked actually quite a while in our public sector team, working with governments and across the world actually, but a lot in the US. And the U.S. government has a pretty advanced model for adopting cloud computing. It had a cloud-first policy, and there's been quite a lot of cloud adoption. They have a compliance regime called FedRAMP. So the idea of being able to do federal risk and compliance in a central organization that says, okay, we're going to bless this cloud or this SaaS offering, whatever it may be, and then federal agencies can adopt that without doing their own compliance reviews, essentially. And the FedRAMP office issues an annual report about cloud security. And what they've said now over the last 3.5 or 4 years they've been in existence, they've, year after year, they report that, yes, there were security incidents in the cloud. They're always the result of customer misconfiguration, customer mistakes. Now, that's not a good thing. Believe me, we're doing everything we can to make that number 0, too. But the point is they've never had a significant incident with the cloud itself, with the FedRAMP authorized clouds, which include, of course, all the major providers and also some smaller players that are only based in the U.S. So the point is that really the key thing is to build and configure and use your systems properly, and because that's where you're going to get targeted. That's where the low-hanging fruit is. Now, all that said, people are naturally curious. Well, what do you do to make the platform secure? So I want to talk a little bit more about that. So the first thing I want to talk about is culture and executive leadership. So as I said at the beginning, we really don't have a business if we don't have a reputation and a reality of highly secure platform. Now, a lot of that reputation is built through experience customers have. A lot of it's built through compliance, third-party audited compliance. So we exist under this very wide range of compliance regimes, all the way from the SOC reports for auditor to auditor to the PCI, compliance reports. These are third-party auditors that do have physical access to data centers. They have access to source code. They have access to process and teams and people and all the internal things that you'd want to know about, that when we say we do X, then we actually do that. And you can now access the information from these third-party auditors that talk about, they provide the evidence, they talk about whether we're meeting the controls or not. And so that helps build trust, because you can now get access to sort of straight story from another party who has no commercial interest in promoting us or not promoting us. They're just going to report the evidence to you. So that helps build trust. But really, from an internal perspective, I think maybe really the key starting point is executive leadership here. So our CEO, Andy Jassy, spends 90 minutes every Friday reviewing security. So that's a laser focus for him. So he goes through any issues that customers may have had, any issues that the platform may have had, anything that's on the radar for all these different service teams. He goes through those, and he is absolutely laser focused on this topic. Now, that creates a culture, okay? So if you're an engineering team leader, and you might think, well, there's maybe this little issue, but, if we can ship, it'll be okay. We have mitigations. But if their CEO's mindset is kind of like, you know what, we don't really take chances on these kinds of things, then you'll be self-policing and self-correcting, and that really permeates down through the culture, through the organization. And it gives the security team, we'll talk more about exactly, we do have a distinct security team, but it gives them a kind of special brand or capability, which is, we're not really going to get into like an argument with you about this thing, because no one's going to back you on that. If we understand the desire to ship, we understand the desire to move rapidly, we accommodate as much as we can. As a security organization, we don't want to be the culture of no, the classic things at security. We'll talk about how we avoid that. But in the end, if a decision has to be made where these issues are in balance, there's an understanding throughout this organization where the CEO is going to come down, right? So that really helps build a culture of high security. We'll talk a lot more about this notion of integration, but security engineering is not done just centrally. We do have a central team, we'll talk about that, but we have, you can think of as champions or security specialists in every single one of our service teams. Every team from S3 to EC2 all the way to Cloud 9 or some of the smaller, more obscure, newer services. There's always security engineers inside those service teams, and they are the sort of the first line of defense, the first line of offense in building security into the platform. And we'll talk more about that interaction, but having that integrated is super important. And even compliance, which often in many companies is treated as sort of this distant thing that's a checkbox exercise, et cetera. In our world, we try to fold that very much into our whole security rhythm as well. Because compliance, if done properly and kept up to date and done accurately, is a very important security tool, because a compliance regime is really just a set of policies that you believe make sense in terms of keeping track of the right way to do things. So that's the background. I'll talk now specifically about the team that I work in and how it's organized. Briefly, to sort of summarize the different subgroups, we have something we call application security. I'll focus a little bit more on that in a moment. Security operations, those are the two that I want to dive in a little bit more on in our limited time here. We have threat intelligence capabilities. We have our assurance team, which is another name for compliance. We also have an engineering function inside the security team that builds the tools that support all these other functions. And so it's clearly we try to live and breathe our own messaging, which is automate. Anything that a human does repetitively, about the second or third or fourth time they do that, they should stop and think, why am I doing this again? Let's automate this. And so we have an internal engineering function that supports automation for all these other teams. Even within those teams, we have people with software development capabilities, because, again, we try to embed that deeply within these functions. But there is a distinct engineering group. And then finally, this Amazon security organization under our CISO also has external security services. So, for example, if you know our platform, things like GuardDuty, things like Inspector, these come out of this organization. And we often incubate security services, like Cloud HSM, for example, was originally launched from within the CISO's team and then moved to, there's another vice president, Kurt Kufeld, who owns a bunch of other security-related technologies in the organization. So that's a brief overview. I'm going to dive in on two of these. In particular, I'm going to talk about this so-called application security, or AppSec, and then operations, or SecOps. So AppSec, this is a weird name, application security. Like, what applications are we talking about here? Well, it's historical, okay? So you got to forgive us for having, everyone has their legacy naming, right? So if you think about when we launched, S3 was an application. So when we build a service, from our perspective, it's an app, right? So this is a bad name, basically. But think of it as, this is a team which helps and guides the service teams, the AWS services, all the way from the very mature and sophisticated ones like S3, EC2, RDS, all the way to the brand new teams that are just launching, or to maybe an acquired company that's launching a new service. This team provides that guidance and that co-ownership of security. Now, again, the key thing here is we don't want an adversary culture. We want a culture of cooperation. And so a key thing this team does is make sure that there's an embedded security champion and security engineers, security experts in every single team that they're working with, that they're partnering with. They want that to be an embedded aspect of that. But they also want to provide a sort of internal consulting service, which is, okay, you're thinking about building a new major feature, a new service. Come to us. We've got threat modeling. We've got experts. Let's do some design reviews. Let's look at your basic architecture. So right from the start, as an external consultative function, the AppSec team will be part of those early conversations in terms of what it is that you want to build. And then throughout the process, again, depending on the significance of the change, if it's a new feature or if it's a new service, that's kind of the maximum engagement. There'll be periodic design reviews. There'll be again learnings from other teams. Every time you learn something from one team, that becomes part of the you update your threat model, so the next team that comes along will be able to learn from that. So this AppSec team is responsible for kind of that database of threat models. And then toward the end of a release cycle, say again major feature, new service. There's lots of small updates going on a daily basis, and they have there's human judgment involved. So you have some much more lightweight processes for those, although the automated pen testing and things still always occur. But anything that's a more significant change will get a lot more attention. And this team will also coordinate the penetration testing. So near the end of that release cycle, there'll be pen testing tools built into the GevOps pipeline, and there'll be lots of security things going on in the meantime. But there is a sort of handoff point where our both internal and external pen testing, white box, black box, everything you can imagine goes on. We have a very large investment in this space as part of just our general software release process. And then at the end, when all is said and done, this team does have a sort of veto power. Like there can be a judgment made. You know what? You wanted to release reInvent, or you wanted to release on this, this schedule. You're just not quite ready. You're going to have to wait a few weeks. You're going to have to solve. We've got a couple more issues that there's a few that we think the risk is acceptable. We have good mitigations. There's a few that we're just not comfortable with, and we're going to have to just delay the launch. And so this team does have that kind of final say about releasing significant features, new services, et cetera. However, I would say that is never, again, it's not a big fight. It's not a big, deeply adversarial process, because this has been a relationship that's been going on now for months and months, and there's there'll be a assigned set of security engineers. So when you come to this organization, you don't talk to a different person every time. You have one or two people who are assigned to you, and through that relationship, we manage these things and maintain very low friction. And again, going back to executive culture, the service team who's eager to launch their cool new feature knows that if it really comes down to it, and the security team is recommending that they not launch that day or that week, then pretty much know what the answer is going to be if it gets escalated to senior management. So that's the AppSec team. I'll talk briefly about AppSec, and then we'll come to a close. So SecOps is our operational team. This is our team, which is watching the platform, watching customer issues, responding to customer concerns, responding to escalations from our abuse team, who may be getting outside notifications. They operate on a 7/24, 365 basis. We out of primarily 4 locations, kind of starting in Seattle, going to Northern Virginia, then to Dublin, and then to Sydney, Australia. And it's a really strong team of cyber engineers who really know operations. They know about log diving. They know how to figure what's going on, and they know how to run problems to the ground. They deal with any high priority alerts that have come in. Their data that they create and the learnings that they have will go feed off into these other teams. So that might feed off to a threat intel team if they see repeating patterns of things. It'll feed off to the AppSec team if they see some issue that we should always be thinking about when we go to release a new capability. And this is really, they're really responsible for taking any issues from high priority down to sort of medium priority where they can get handed off back either to the service team or back to a customer who has called and said they're having a bad day. So this team essentially works in this global and coordinated fashion. Now, one of the things that people often ask is, well, can I tour your SOC, your Security Operations Center? And our answer is, well, we don't really have one. It's really boring. It's basically 4 conference rooms around the world. They always have a video feed up. And then surrounding that, a bunch of cubicles where people are actually doing their work. So they can get them into the room if they need to have a quick conference or discussion. And at those moments of handoff, so every 6 hours there's a handoff with all priority issues identified, official handoff. There's a tool that's used to sort of make sure that all issues are known. So there is interesting and very sophisticated human activity, but there's no theater. There's no big screens on the walls. There's no pictures of packet flows or things like that. So it's kind of boring, but it's been working well for us. And so I think my time is up, and I'll be happy to hang around and take some questions afterwards. Or I don't know if we take any questions during the event. Nope, we're going to move on. Okay. Well, thank you very much for your time. I really appreciate it.